Friends, welcome to the fourth lecture in module 4. Here we are going to continue with the discussions on SHM design for BSLRP in the lab scale, which we discussed in the last lecture. This is the second lecture in continuation with the previous one. If you look back at the summary in the last lecture, we said that the sensors are now chosen with few additional requirements. Namely, it should have a reduced settling effect, it should also have the control of sensor drift. So, keeping this in mind, sensors have been chosen. We need to also measure both fast and slow acceleration and displacements, because the platform will exhibit both kinds of characteristics under the wave load. The sensor modules feature also a user programmable full scale range. Of plus minus 250, plus minus 500, plus minus 1000, plus minus 2000 degrees per Celsius, the DPS for the inclinometer, and plus minus 2G, plus minus 4G, plus minus 8G and plus minus 16G for the accelerometer. So, the present study focus on plus minus 2G range for accelerometer with sensitivity of 16382 LSB per G. Internal registers for memory are enabled for accessibility we have used I2C at 400 kilohertz. Alternatively, one can also use an SP1 at 1 megahertz, which is the signal serial data, and a signal clock, which is a serial clock. The present study uses SCL, okay, serial clock. Now, these lines are bidirectional. Therefore, the sensor module can either act as a slave or as a master. So, that is what we call scalability. So, MPU 6050 generally acts as a slave, but while communicating to the processor, it acts as a master node. It is connected to the processor board through GPIO pins, so which enables both sensor nodes and the processing unit to acquire the data and also transmit the data. To base station in parallel. The description of MPU pin, which is 6050, is given below. So, there are many pins available. Let us see the name, number and the description of the pin which is being used in the present study for 8, 9, 23 and 24. The name is V logic, AD0, SCL and SDA. The description could be, this is a digital input output supply voltage. So, V logic must be less than or equal to VDD at all times. Okay, that is the condition for operation. This is 12C slave address LSB. This is corresponding to 12C serial clock, as I said in the earlier point. This is 12C serial data. In addition, AFS SCL, which is a 2-bit unsigned value of accelerometer, at the HEC address 0x1C is used to select the full scale range of the acceleration automatically. The gyroscope configuration pin is allotted the hex address 0x1b, which is set to trigger the gyroscope self test and also used to configure for full scale range. The 06xB is the power management register which is actually PMGMT, which configures the device power mode and the clock source. While the 6th bit of this register will reset the device when set to 1. So, by this way power mode can be either set to sleep or cycle mode automatically. So, you can save lot of power. The device switches between the sleep and cycle mode are also set to acquire a single sample rate specified by LP wake control register. The 12C MST control configures the I2C bus for the multi master control and 8 megahertz internal clock. These registers are initialized at the initial step at the first step of configuration. This is done by using an interface code which is indigenously developed by us. At IIT Madras. The pin configuration for initializing the device is executed using the following code. Which is self bus write by data 0x668, 0x6b, 0x01. Similarly, self bus write by data 0x68, 0x1b, 0x00. Similarly, self bus write byte data 0x68, 0x1c and 0x00 are used for configuring the pin initially. For each axis, offset values are calculated so that the error in the actual acquisition can be adjusted for the measurements. The actual error may occur due to the offset and drift value. So, they are adjusted in the beginning itself. In the pin MPU 6050 module, 3 numbers of 16-bit analog digital converters are used to read the accelerometer output in all 3 axes. For example, to read the x axis output, ACCEL axle x out h and ACCEL axle x out L are the 2 registers which will have 8 bits each. Now, data within the registry is continuously updated at the desired sample rate. In case it fails, user can check whether it follows a single byte reading corresponding to single sampling instant. All the required library files are included to read and write with the register values. 16-bit value is first read, that is the sequence of reading, and then the complete value is considered for data processing. This is being done for all axes. Okay. Now, interestingly, the code used for reading the abscissa value from the acceleration output register is given below. One can see this is the code used for reading the abscissa value for the acceleration output. Okay. Interestingly, 2 major factors are considered while dealing with the sensor measurements. One is the noise reduction and second is the number of outliers. Because both will degrade the validation of results. So, they should be checked. Now, interestingly, the source of noise may arise from various factors. One, presence of thermal noise coming from the temperature variation. It can be electromagnetic interference, it can also be due to sensor oscillation if it is not firmly fixed. It can be due to quantization of the noise.